Now that we've looked at ways to get random samples, let's look at ways to get, or simple random samples. Let's try to get a little bit more control. As I talked about before, what if I did do that random sample? So I did my random number generator, I got 100 students, and it just so happens those 100 were the first 100 that would have walked into school that day. Now, we don't believe that group's necessarily representative of the school. So maybe I feel like I need a lot more control on my samples. I don't want purely random. I want a lot more control on what's going on. So one of the things we can use is what's called a stratified random sample. Stratified, so strata meaning like layers or levels. Okay, so we're still gonna have some type of randomness in there, but we're gonna stratify the sample first, or the population first. So when we have a stratified random sample, we're going to organize the population into subgroups. By some key characteristic. Some relevant characteristic. So maybe if I thought grade level was the most important trait that might influence how students can answer this question, I could group students by grade level. So if I group those students by grade level, well, once I've got them separated into freshmen, sophomore, juniors, and seniors, what do I do with that? Okay, do I want to talk to only one of those groups? No, the whole point of organizing was because we thought we needed a little bit of each of those groups. So once we've selected those, we then want to, or once we've organized by subgroups, we want to randomly select, so there's our randomization, individuals from each subgroup. So randomly select, we'll say a few individuals. So that may look something like this. Here's my population of Riverdale again. And now I've subgrouped it into my 4 grade levels. Okay, paying attention that my grade levels are all about the same size, so I want to make sure I get groups that are about the same size. So we could separate students by grade level, and then we could randomly, whether we did everybody in one grade level's name on a slip of paper, or we assigned everybody a number and then randomly generated some numbers. So we could randomly select 25 students from each grade level. Right? Or if we know that the senior class is a little bit bigger than the junior class, maybe I want 30 students from the senior class and 20 from the junior class. We see that kind of happen a lot, like again with the presidential pollings that are going on right now. They'll try to make those groups look like what's going on in the population, where it's about 30% Democrat, 30% Republican, 40% Independents. They'll do similar type things there, where they want their sample to kind of have a similar type breakdown. All right, so once I've got my subgroups, I don't talk to everybody in each group. I'm going to get a random sample of a few people from each subgroup. So 25 here, 25 there, 25 there, 25 there. Now I've got my 100, and I've controlled for a very important characteristic that I think plays a role in how they're going to answer the question of, opinion of the administration. So that's a stratified random sample. Now another sample that, in this situation, I don't think it's as good a type of sample, but there are some scenarios where it is. So cluster sampling. So cluster, I think cluster is kind of grouping things, right? So kind of putting things together. So clusters are usually things that are natural groups. So if I'm sitting here and I'm wanting to survey about an upcoming election like statewide, maybe I don't want to talk to, maybe I don't want to just do it males and females, or just do it Republicans, Democrats, Independent. Maybe I think where you live plays a role in how you're going to answer this question. So maybe people that are in the cities will probably have a different preference for a candidate versus people in the suburbs versus people in the rural areas. So those could be clusters. So what I could do is I could say, okay, this cluster, this rural area is going to be part of my sample, and this suburb area is going to be part of my sample, and then this urban area is going to be part of my sample. So I'm grabbing people by those clusters, by where they're physically located towards each other. So a cluster sample, it's not always about physical location, but generally that's kind of what we go with. So whether it's by where you live, or what floor you work on, or maybe things that are in a similar packages. So if I was looking at packages of potato chips, one bag of potato chips would be a cluster of those types of chips. So that's typically what we mean with cluster, but it really could be anything. So this definition kind of gets a little wordy and technical, but usually the idea is that we're looking at kind of things that are naturally, physically located close together. All right, so a cluster sample says we're going to organize the population into subgroups that each contain many key traits of the population. You may hear the words later on when you're taking other courses about a heterogeneous group. So there's a lot of different characteristics. So I can look at grabbing like one rural county, because that one rural county will have Republicans, Democrats, Independents. It will have males and females. It will have wealthier people and poorer people. So there are a lot of the characteristics of what's going on in the population in that one county. So I'm still getting a lot of those traits, but I'm making sure that I've definitely got them grouped or pulled in based on where they live, that type of thing. So organize the population into subgroups that each contain many key traits of the population. Then what we want to do is randomly select a few whole groups. A few whole groups. All right, so if I'm looking at my population of RHS here, of Riverdale, maybe I'm grouping them by, some small characteristic, small trait. So what if we just grab by first period teacher, right? Each first period should have a different mixture of students as far as genders related. Maybe it has a different mixture of students as far as ability level, whether you participate in different extracurricular. A lot of first periods have different grade levels within them. So each one of those first periods could be considered a small little subpopulation of our greater population of Riverdale. So I could group students by first period all right, so, and then randomly select. Well, so how is this different from stratified? Here, I put them into subgroups. Is this just smaller subgroups? No, the difference is right here. When we do stratified random sample, we want to select from each subgroup. I grab 25 people from this group, 25 from there, 25 from there, 25 from there. All right. When we do a cluster sample, we want to select whole subgroups. So I'm not just talking to a few people in this classroom, I'm talking to everybody in that one, and everybody in that one, and everybody in that one. So I'm looking at whole subgroups. So I'm going to maybe randomly, instead of randomly assigning numbers to students, I randomly assign them to a classroom. Say, all right, I want classroom 100. I want classroom 32. I want classroom 74. I want classroom 42. I want classroom 2. And then we'll talk to every student. So I'm going to randomly select 5 classrooms, because the classrooms may have, anywhere 15 to 25, 35 students in. So randomly select 5 classrooms, and then interview every student in each of those rooms. So this is the big thing with distinguishing between stratified sample and cluster sample. Both of them you're putting in the subgroups. One, you're getting a few people from each subgroup. Here you're grabbing everybody within a subgroup. Now, as I explained before, we could do combinations of all of these and do, like I said, multi-stage sampling. But for this course right now, I just want you to think of them as individual things. Simple random, everybody in the population can be chosen, has a chance to be chosen. Stratified or random sample, I'm putting them into subgroups and then doing a little bit from each subgroup. And then cluster sample, I'm putting them into smaller subgroups. I'm talking to everybody within a few subgroups. So instead of a few people from every subgroup, it's all people from a few subgroups. All right, so that's our best ways, or that's the ways that we have right now to be able to get representative samples, samples that look like the population. All right, so now that we know how to get a good sample versus a poor sample, let's look at how we can interact with people and do some surveying and talk about things we do and don't want to do when we are gathering this information from individuals. All right, let's look at some errors in surveying. Surveying is just where we ask individuals questions or we make observations, and we just kind of write down our observations or how they responded. So some things that can kind of go wrong. So this first scenario we've got here, we randomly selected our 100 students. So we did a simple random sample, got 100 students, and it came out to be 10 were freshmen, 50 were sophomores, 15 were juniors, and 25 were seniors. This right here would be an example of what we call under coverage. Well, why is it that we think that this is an example of under coverage? Well, under coverage is where you're going to under represent key groups in a population. So as we can see, we way oversampled the sophomores. There's no way sophomores are 50% of our school, okay? So underrepresented key subgroups in the population, well, we had way too many sophomores, and it looks like our freshmen and juniors were way underrepresented. So that's under coverage, not covering enough of each of those important subgroups, which is a way we can kind of help with that is doing a stratified sample or something like that. Or maybe we just only wanted to talk to seniors, and we just talked to 100 seniors. Again, that would be under coverage. We're not representing enough of the school. All right, another type of surveying error we could have. So I'll send a survey to 100 students from the stratified random sample. So we made sure to get a good mixture of sophomores, junior, freshmen, and seniors. And we send out those 100 surveys, but we only got 74 of the surveys back. Okay? We needed 100 to feel like we get a good picture, but we only got 100 of them back. That would be an example of non-response. So non-response is people choose not to participate. So even though we did everything right in selecting the right kind of people, those people chose not to participate. Since we don't live in a country where we can force people to participate in surveys and things like that, we kind of just have to take that. So ways that around that, maybe we say we know we need 100 and typical participation rate's about 75%, so maybe we send out 130 surveys, something like that. So that's a way that we could kind of work around that. All right, next we have something that we call response bias. What is response bias? So how can you have bias in your response? Well, think about what bias means. It means we're overestimating or underestimating what's going on in the population. We're not getting a good picture of what's going on. So let's say that I'm asking somebody what's your opinion of the current school administrators, and I'm asking that as the principal's walking by or as the principal's standing there. So we're out, we're trying to collect data, we're trying to get information, and we're wanting to know about the administration, and the administrators are standing there observing how students are responding. What kind of response do you think the student's going to give in that regard? Well, you'll have a few students that are like, I'm going to stick it to the man, I'm going to say something mean, even if I don't mean it, just to try to rile things up. But you'll get a lot of people that are just want to avoid the confrontation, and they're just going to say what they think the administrator wants to hear because they notice that they're right there. All right, so response bias, the idea is people lie. That's what response bias is. It's when people don't give an accurate answer. This is something that we're seeing a lot right now. We saw a lot back in the 2016 election. You may have heard of something called the shy Trump vote. A lot of pollsters used that to and pundits used that to explain why the polls were saying one thing going into the 2016 election, and then the results of the election came out to be very, very different. And what they went back and found was there were a lot of people who, when they were alone in the ballot box, ready to pull the lever or push the button for a candidate, they were more than willing to vote for President Trump. But when somebody asked them who they were voting for, if a pollster asked them, they didn't want to be judged. They felt like they were going to be judged personally if they had to tell that person for whom they were going to vote. We've seen this before in other elections. The Bradley effect is another example of it, where you had, I think it was somebody was running for mayor. So the Bradley effect, you had, I think, a black guy and a white guy were running for mayor, and a bunch of people said, yeah, I'll vote for this guy right here for the black candidate. But then they ended up not pulling the lever for him, and so they found out they said what they thought people wanted to hear, but then they really weren't comfortable actually voting for that person. So these are a couple of examples of response bias. So when we are designing a survey, and we know that people lie, especially when there's the chance that they feel like they're going to be judged, if they're trying to just do things that are non-confrontational, we need to design our study to be able to gather accurate information, representative information. So you've got to figure out a way, how can I make people comfortable with giving a truthful answer? And maybe that's make sure things are anonymous. Maybe we can do things where they're not having to live interact with another person. Maybe we can just set up some type of digital response to where they're not having to, again, risk them being judged by the person that's recording their responses. So because of response bias, we need to figure out ways to design our surveys and design our studies to minimize this and get truthful responses from people. And then the last one is wording of questions. How can question wording make for an error in a survey? Well, let's look right here. Let's say this is the way I worded my question. Considering the short lunches, small amount of time between classes, and strict tardy attendance policies, what is your opinion of the current school administration? That's, first off, a very wordy question, but notice how there was a tone to that question. How is somebody going to respond when you've pointed out you don't get long between classes, you don't get very long lunches, and given all that stuff you don't have a lot of time for, they're going to hammer you on being tardy or missing class. So with all these negatives, what do you think somebody's going to, how they're going to respond? They're going to respond most likely with a negative opinion. Okay, so when we have questions questions that are confusing, meaning they're using a lot of big words or technical language, or it's a long run-on sentence, or if they're leading questions, they're trying to guide you towards a specific response, those are not going to give you reliable results because you're not, reliable response. So what happens is you're not really getting that person's opinion. You're getting that person's opinion after you've set them up in a certain way. So when you design your studies, when you design your surveys, you want to make sure that they're kind of emotion neutral questions and they get right to the point. They don't drag on, people don't lose their train of thought, and they don't get confused by what you're wanting to ask. Don't ask things with lots of nots and no's and nothings, double negatives that can cancel stuff out. Yes, so keep them clean, keep them concise, and keep them emotion neutral so that we can get a good, accurate representation of what these people's opinions are. Now, of all these errors, got one little activity I want you to do right here. Some of these are what we would consider a sampling error, and some of these are non-sampling errors. So sampling error and non-sampling error. I want you to take a minute, so I can pause this, so take a moment, and then just out beside each one of these, I want you to label, is it a sampling error or a non-sampling error? So you kind of come up with your own definition based on what these mean. Come up with your own definition of what those are, and see if you can figure out how you would identify each one of these. And I'll wait right here. All right, hopefully you got something that looks like this. All right, so as we can see, under coverage is our only sampling error up here. What do we mean by sampling error? It's an error in how we got the individuals for the sample. Okay? An error we messed up on gathering our group together, putting our group together. So we did a random selection. We didn't do stratified. We picked a non-representative group. So that was an error in how we picked those people. The other ones were non-sampling errors. We did a good job of getting our people. So we had our 100 students. We had our 100 random stratified students. Maybe we had 100 random stratified students here and here. So we did a good job of picking the individuals. We messed up in how we interacted with them. So a sampling error is an error in how you choose your individuals. Non-sampling error is an error in how you interact with the individuals. We didn't give ourselves enough room to account for people choosing not to respond. We didn't set up in a way for people to feel confident and comfortable being truthful. We did not word our questions to give us a good, true, non-biased response. So that's what I mean by non-sampling error. We made an error in how we interacted with the people versus how we selected the people. All right, so this is kind of what I want to talk about there with. All right, so that's it for sampling and surveys. So poor samples, convenience and voluntary. Representative samples, simple, random, stratified, and cluster. And then types of errors to avoid when we are doing our survey and generating our samples. All right, that's it, and I will see you guys in class tomorrow.